Hello and welcome to the podcast. It is common to present philosophers as if their ideas appear fully formed in polished books. But with Leibniz things are very different. Most of his thinking survives not in finished works but in drafts, sketches and fragments, pieces of larger projects that were never completed. To understand what Leibniz was trying to do, we therefore have to build a narrative between texts. By placing manuscripts next to one another, we can see how one idea develops into another, and how a modest proposal can evolve into a much more ambitious project. In this episode, I want to show how such a narrative can be constructed. We'll be narrating Leibniz. Our story begins in the summer of 1679, when Leibniz sketched the idea for what he called a little book on the art of mathematics. In a short text, Leibniz proposed introducing a new analytical method, one that could solve problems previously thought impossible. The method itself is not described in detail, but we know what he had in mind: his newly developed differential and integral calculus. The aim of the book was straightforward. Leibniz wanted to present the method and demonstrate its power through examples. At this stage, the project was essentially mathematical. But even here, we can see the seeds of something larger. Soon afterwards, in another draft called Preface for the Key to Secret Mathematics, Leibniz greatly expanded the scope of the proposed book. Instead of presenting only a new analytical technique, he now imagined a work that would begin with the origin of numbers and mathematical characters, and then move through a remarkable range of subjects: arithmetic, algebra, geometry, optics, mechanics, astronomy, architecture, even military science. The project had begun to grow, and it continued to evolve. Another draft from the same period, entitled Elements of Mathesis for the Use of Beginners, suggests that Leibniz was thinking not just about mathematics narrowly conceived, but about mathesis universalis, a universal science concerned with order and measure in all domains. Here Leibniz was drawing on an idea that had fascinated philosophers since Descartes: the possibility of a general science underlying all mathematical disciplines. But the most revealing text from this period may be another piece that has a rather formidable title: On the Characteristic Art and Analytical or Combinatorial Discoveries in Universal Mathesis. This text may represent the bridge between Leibniz's initial mathematical book project and the much broader program that followed. In it, Leibniz describes what he calls a general art of discovery. He explains that discovery operates through two complementary methods: analysis and synthesis. Analysis works by breaking down complex concepts into simpler ones in order to determine their essential components. Synthesis, by contrast, proceeds by combining simple elements to generate more complex structures. But methods alone are not enough. Discovery also requires instruments for thinking, and Leibniz proposes two in particular. First, characters, symbolic signs that make analysis clearer and more precise. Leibniz believed that many of his own mathematical breakthroughs had resulted from improvements in symbolic notation, not least the notation he devised for differentiation and integration. Second, Leibniz proposes tables and inventories, carefully organized displays of knowledge that reveal relationships between things. Together, characters and tables form what he called a thread for thinking, a systematic method for discovering new truths. At this point, we can see that Leibniz's ambitions were expanding. The project was no longer simply about mathematics. It was becoming a proposal for a universal method of discovery. and in 1680 the project underwent another transformation. After failing to secure support for an earlier proposal to compile a vast encyclopedia of knowledge, Leibniz began to rethink his plans. In a text entitled Directing Studies to Happiness, he observed that completing an encyclopedia would require enormous labour. What was needed in the meantime, he argued, was something more manageable, a general science containing the primary principles of reason and experience. This new project, the general science, would provide the intellectual tools needed for discovery across all fields of knowledge. Leibniz soon began drafting introductions to a projected book titled Foundations and Specimens of the General Science. The structure of the book is revealing. The foundations consisted of two parts: the art of judging, which would evaluate propositions and determine their truth or probability, and the art of discovery, which would generate new knowledge. The specimens, meanwhile, would demonstrate the power of these methods in practice. And here the story comes full circle. The examples Leibniz planned to include came from the very fields where he had made his own most important discoveries: geometry, mechanics, mathematics, and physics. In other words, the General Science Project was not only a philosophical program, it was also a way of presenting and promoting Leibniz's own research. Seen in this light, the development from 1679 to 1680 becomes much clearer. What began as a little book on mathematics gradually expanded into a proposal for a general art of discovery, and finally into a comprehensive project for a general science that would transform the organisation of knowledge itself. This is what it means to narrate Leibniz. By placing these manuscripts side by side, we can watch a project evolve in real time, moving from a practical proposal about mathematical methods to a sweeping vision for the renewal of the sciences. And that's one of the great rewards of working with Leibniz's manuscripts. They allow us not only to read his ideas, but to watch them develop. Thank you for your kind attention. Almost 60 of Leibniz's writings on the art of discovery and the general science are included in the new 3-volume edition of his philosophical papers, the vast majority of them appearing in English for the first time. In the next episode, we'll look at how placing manuscripts next to each other can reveal an entire project that before was little known: the Apology for Catholic Truth project of 1685. We'll be reassembling Leibniz.